Make this as quick as possible. I think what I turned in yesterday was pretty shoddy, so I'm going to do level 2 structured STEM inquiry, skeletal form and function, spooky science. The resources are listed all here. I'm not going to get into all that. The students who demonstrate understanding are going to ask related questions related to the engage and explore pieces and search for terms to describe or explain observation, comparing pouring H2O into nothing as opposed to pouring H2O into several sturdy structures, which I won't demonstrate right now. So the engage, I'm going to skip down to the engage, is that for morning work they're going to have, I got this idea from you guys, I thought it was an immaculate idea. All these things, and this is the yes tables. There would be a lot more tables in this. I've got all this stuff crowded on one table. Well, I've got 2 tables over there, but I would have like 3-4 tables, and these would be yes tables, and they are allowed to come along over here for morning work when they've done all of their other stuff, put their stuff away and everything, and they're going to look at, you know, all these things and pick them up and do, you know, what are they going to do? There isn't anything on this table that you can't touch. What the heck is that for? Rubber bands? What's this? Looks like it came from the doctor. What's that? Ah! Hey, Miss J, can I try it on? Well, it is the yes table after all. And we've got other things, Bones books, and just some sturdy, you know, flimsy things. Table over here, cardboard box that's holding something delicate and breakable. The Great Wall of China, which is just a photo, but some other, you know, skeletal, structural types of things. You can see here, popsicle sticks, a skeleton. Oh. They're not spooky. We all have one. And then down underneath, there's some things down there. Like, I thought this was cool. What would happen without a skeleton? Yowzers. And so I had this melted candle in this thing. I thought that would be pretty cool. Anyway, so that would be my engage piece. As for the disciplinary core ideas, it's going to be structure, form, shape, and function, and how they relate, systems and modeling. Non-solids have no stable form. So, you know, like a cloth, you know, like you know, any kind of a cloth object or water or liquids and things like that. They don't have, we're going to learn about something called an amoeba. They can kind of take different shapes. They're flexible. So anyway, then we go to, on the Explore, they're going to be given a plush animal, and I didn't put those out. I can't believe I didn't do that. But I have these sturdy plastic animals. They're not pumpkins. They're real. I mean, like jaguars, lions, polar bears, horses, and they're plastic. They're sturdy, and they're going to observe these. They're going to be at their tables. They're just going to examine them. They're going to feel them. They're going to and they're going to feel both, and then they are going to, after they just examine them carefully, they're going to draw both in the journal and use any words that they know to describe the difference in their shape, texture, and structure, how they feel. And they have 20 minutes, and they have to work in pairs, and then I tell them you can go. And then the next thing is the explain piece, which I'll take you in here for this, because then I do some stuff. Like I have this video about bridges and why they're sturdy. And then an observational experiment with sound and what it can do to sturdy objects. So, like, for example, we might have a video like this. And, let's see if I can do this without that. Okay, it's concentrating on a different type of structure, like bridges, but I need to speed it up a little.
Oh, hi guys! Squeaks and I were just playing with some blocks. You know, it may not seem like it, but the cities and towns that we live in are all built using the same rules as our little pretend village over here. It's just standing. So she sent us a really great question. Why are bridges so strong? Excellent question. Sometimes when a road or railroad track needs to go across something big like a river or a deep valley, experts called engineers
as you can see,
design and build
it's going to
bridges
be,
to do that
it's
job.
related
and bridges
to,
can be really busy. Take, for example, what's said,
you know, structure and form, and it relates back to the skeleton. And then the other thing, well, I don't know if, I think this video shows it, but we talk about and see a video on the Tacoma Narrows Bridge. And how this very sturdy concrete and steel is moving and bending and waving due to these factors that first graders can be exposed to. They may not comprehend them, but I can tell them that there's this thing called resonance and show them a video of the wine glass and the cylinder that after so much time, the humming sound matching the frequency of the glass will cause the glass to break and stuff like that. It's just exposure. And then I might show them something like this and just have them observe it. And I don't want them writing or anything right now. I just want them observing. I started on medium volume maybe. I've got this seated on top of a woofer. I might turn the volume way up and see what happens. And I want them observing. Basically, if I can find my little sheet again, I like music to be in the background. Basically, what it's going to lead to is they're going to then write in their journals 2 things they observed, either from the video or from the demonstration, or one from each. And they're going to use sketches and labels and vocab that we've just learned, which I will have listed, to replace the vocab they've been using to search for ways to describe. And then the final thing, it combines extend and evaluate while they're doing the extension. And since this is a level 2, they're not going to come up with their own. I'm going to come up with it for them, and I don't know if that's illegal. What are the STEM laws? Am I going to be apprehended? But anyway, so I'm going to be evaluating as they do this project. So they all are divided into teams. Each team has the same materials. So you've got, if I can open this door, we'll get more light. You've got these materials: string, paper clips, tape, scissors. You'll also have rubber bands, which I failed to put in there. Newspaper. That was not meant to be there. Everybody gets a newspaper. These are your only items, except for you also all get this skin. This transparent, it's a shower curtain, but I call it just a floppy skin without a skeleton. And the goal for the students is that they need to, create a structure for your skin swath using only the materials given. First, draft a sketch and brainstorm together with your team, then find a spot, and then begin to build your structure. And you have 15 minutes, and the structure that withstands my shake test wins. And so that's basically, and then I wrote down here a question: can I be evaluating as they do the extend project? But anyway, this is Kale Johnson speaking to you from Woodstock, Kansas. I wanted to submit this because I think what I turned in yesterday was pretty shoddy, because I needed some time to process this stuff. But this is what I'm going to do. I want to try this. Skeletal form and function. Spooky science. Well, I didn't show you everything. I mean, it basically focuses on structure and function, but it's also systems and models. I mean, why do we have a skeleton? They're going to learn that it's not just so that the skin has something to move around with. They're also going to learn that there are soft tissue organs that are very delicate in there. And those soft tissue organs need protection, and the skeleton serves. This is Dr. Seven. His full name is Dr. Cervical Vertebra. This is Kale Johnson speaking to you from Humble, Wichita, Kansas. Thank you for taking the time to, oh, and there's my assistant, to watch this video. Thank you. Bye.